Hello everyone. This video will demonstrate how to generate random, evolving melodies and patterns with Ableton Live, using no pre-recorded audio or MIDI loops. Instead, we'll be using Ableton's CV tools and a small case of modules, which includes an Expert Sleeper's ES9 as our audio interface, and 4 modules from Make Noise, which includes a dual VCO called the DPO, an envelope generator called Contour, a dual low-pass gate called Dynamics, and a voltage-controllable audio buffer called the Morphogene. We also have a semi-modular synthesizer from Make Noise called the Zero Coast, which will be functioning as a group of utilities and modulation sources for the patch. Later, we'll be removing all the cable and repatching from scratch with an explanation of all of the connections. Now, in place of audio or MIDI loops, we'll be using sequencers like the Probability Pack by Sonic Faction, which is a free add-on for Ableton 10 Standard, and a Max for Live device we see here called Asteroids by Isotonic, which is generating the piano notes. This device contains 8 sequencer engines, which travel around an 8x8 grid, triggering a MIDI note whenever they collide. Each sequencer engine has its own clock settings, and the direction, along with the chance of a note being generated, are randomized. The notes from Asteroids are sent to Kontakt, loaded with a piano called the Maverick, and the audio from Kontakt is sent to the Morphogene, where it's processed as a type of granulated echo. From there, the output of the Morphogene is sent back to Ableton through 2 inputs on the ES9, where it's processed by Ableton's low-pass filter, delay, and reverb. The melodic probability sequencer is handling the main synth voice, where I've programmed a 16-step pattern with some octave switching on a random G-sharp minor pentatonic scale. Those notes are sent to the CV instrument from CV Tools, which uses the CV outs of the audio interface to trigger the envelope from Contour and calibrate the pitch of the first VCO, which we'll see later. Here we're processing the output of our synth voice with a bandpass filter modulated by 3 LFOs from CV Tools, followed by Ableton's delay and reverb. The first LFO is mapped to the filter's cutoff, the second LFO is synced to Ableton's clock and is modulating the rate of the first LFO, and the third LFO modulates the offset of the first. Another melodic probability sequencer is handling the bass, advancing every 2 measures with a random note from the same G-sharp minor pentatonic scale. The CV instrument is sending pitch to the second VCO, but instead of a gate, we're going to use its built-in envelope to send to the bottom channel of the Dynamics. The group channel for the bass is similar to the main synth voice, where we have a low-pass filter modulated by LFOs from CV Tools, followed by a delay and reverb. Here we have 2 LFOs from CV Tools being used to modulate the hardware. The first is a stepped random LFO sent to the Morphogene's gene size input, as well as the Contour's onset input. The second is a square LFO, which momentarily raises the Morphogene's octave and also triggers the Zero Coast, sending an FM burst to our synth voice. Last, we have the erratic tempo fluctuations to Ableton's clock, which has been having an effect on all of our tempo synced effects and LFOs. Here, we're using the CV Clock In plugin and a square LFO to set the clock, and a tempo-synced random LFO mapped to the rate of the square LFO, which provides the fluctuations in tempo. The amount of randomness and overall speed can be dialed in with the depth and offset controls. Let's switch on our first LFO and route it to the first CV output on the ES9, and we'll route the second LFO to the second CV output. Note that CV outs 1 to 8 on the interface are seen as outs 9 to 16 in Ableton. Here we're using a stackable cable to send the random LFO to the Zero Coast's attenuverter to be used later, and the gene size input on the Morphogene, which controls the size of the playback window. We'll use another stackable cable to send the square LFO to the Zero Coast's gate input, and the Morphogene's vari-speed control, which will periodically raise the octave of the buffer. Using one last stackable, we're going to patch the slope generator of the Zero Coast to the Morphogene's slide input, set it to loop, and this will modulate the start position within the playback window. Here I'm connecting the stereo inputs of the Morphogene to a pair of outputs on the ES9, which will send audio from the piano into the Morphogene. Then we'll send the stereo output of the Morphogene to a pair of inputs on the ES9 to process the Morphogene's output with Ableton's effects. Now let's press play on Ableton's transport and see how we did so far. To create our granular echoes, I'm going to record a short loop, stop the recording, and then re-enable recording, which will overwrite the loop instead of an overdub. I'm going to adjust the mix to fully wet so we hear just the echoes. The right side of the Morphogene's LED indicator turns blue when our square LFO from CV Tools raises the octave through the VariSpeed CV input. Next, let's calibrate our VCOs. We'll start by sending the triangle output of VCO A to the top channel of the Dynamics, and the Dynamics output to one of our audio inputs on the ES9. Next, we'll connect the cable which will be used for pitch from one of the ES9 outputs to the 1V per octave input on VCO A. Let's switch on the CV instrument. We have our trigger already mapped to its intended output on the ES9, as well as the pitch output we just connected to the 1V per octave input on the DPO. We're going to click Calibrate, and we'll raise the volume on the Dynamics. Let's advance to the tuning page, and we need to set the pitch to C3 to begin the calibration process. This is going to give us very accurate tuning across a very wide octave range. And then click Start to begin calibrating. And please note you can only keep your effects switched on if they're placed after the CV instrument, which is the case here. Now that we're calibrated, let's lower the volume on the Dynamics. And we're going to patch the output of Contour, our envelope generator, to the control input of the Dynamics. And we'll patch the trigger coming from the CV instrument in CV Tools to the gate input of Contour. Next, we're going to repeat the calibration process for VCO B on the DPO, using the bottom half of the Dynamics to our interface this time. Although we intend to use the wavefolder output on the DPO, we'll get better calibration using a simple waveform shape like the sine wave output for now. Here we're connecting the cable to be used for pitch, and patching that to the 1V per octave input on VCO B of the DPO. Let's switch on our CV instrument. Our pitch output is mapped to the cable we just used, and we'll be using the CV instrument's internal envelope to our low-pass gate this time. And let's turn up the volume on the bottom channel of the Dynamics to begin calibration. Now we're going to lower the volume and patch the envelope generator from CV Tools to the control input on the bottom channel of the Dynamics. We're also going to switch the sine wave to the wavefolder output. Now we're going to make use of the zero coast that's being triggered by the square LFO from CV Tools, and send the zero coast's output to the linear FM input on VCO A of the DPO for some periodic FM bursts to our synth voice. We're also going to patch the stepped random output to the DPO's angle input on VCO B. Next, we'll patch our attenuated random LFO from CV Tools to the Contour's onset input, and this will modulate the envelope's attack stage, randomizing short and long attacks. And we're going to make use of the stackable cable coming out of the cycling slope generator and send that to the shape input on the DPO. Here is where we'll set our erratic Ableton clock by routing a square LFO from CV Tools to the CV Clock In plugin. And right away we can see the rate of the LFO adjusting Ableton's tempo. Next, we're going to map a tempo-synced random LFO to the rate of our square LFO, which will randomize Ableton's clock within the range set by the depth and offset controls on the random LFO. Next, we will map the LFOs to the bandpass filter processing the main synth voice. We'll start by mapping the first sine LFO to the filter's frequency, the random LFO to the first LFO's rate, and the third LFO to the offset of the first. Then we'll do the same for the filter processing the bass, but this time there's only two LFOs, the sine wave mapped to the filter's cutoff, and the random tempo-synced LFO mapped to the first LFO's rate. Let's reset our transport. We're going to turn up the level knobs on both channels of the Dynamix. And we're going to connect the final patch cable I forgot to patch earlier, which sends the mirrored output of the contour to the DPO's fold input. And we'll press play to test this out. Please feel free to ask questions in the comments. And check the links in the description for all of the hardware and software seen in this video. And thank you very much for watching.